Hello students at home, this is your vaporized channel, Helix Chem. Today, you want to look at the topic, half reactions. Half reactions. What is half reaction? Half reaction is concerned with redox equation. When you have a redox equation, the equation can be split into two. What am I saying? When you are given a typical ionic redox equation, they may ask you, or they can ask you to split the equation into two. And what are these two half reactions? We have oxidation half reaction, and we have reduction half reaction. So these are the two half reactions that a typical ionic redox reaction can be split into. This oxidation half reaction, by definition, it has to do with electron loss. Electron loss, that is loss of electron. While reduction half reaction has to do with electron gain, gaining of electron. So if you look at these two, oxidation has to do with electron loss, reduction has to do with electron gain. So when you look at these two reactions, you will agree with me that the two reactions complement each other. While one is losing, another one is gaining. Let's take it one by one. Let's look at oxidation half. How will you write oxidation half equation? If you want to write oxidation half equation, you will consider the definition of oxidation in terms of 1. Oxidation number, and 2. in terms of electron transfer. These two definitions of oxidation will help you in writing the oxidation half equation. When you go by oxidation number, oxidation means a reaction where there is increase in oxidation number. There's increase in oxidation number. Going by the second definition, electron transfer, oxidation involves loss of electron. So, having considered these two definitions now, you will be able to write your oxidation half equation. I will use a typical example for you that will help you to write oxidation half equation. What is the question? This is the question. Question now. FeSO4 3 plus 2Ki aqueous to give 2 FeSO4 aqueous plus K2SO4 plus I2. The first thing is to write the ionic equation for this. So ionically, you can say that this is Fe 3 plus aqueous plus 3SO4 2 minus aqueous plus 2Ki plus aqueous plus 2I minus aqueous to give 2Fe 2 plus aqueous plus 2SO4 2 minus aqueous plus 2K plus aqueous plus SO4 2 minus aqueous. So you have to eliminate the radicals. You have to eliminate the radicals. So if you look at this now, this is 3SO4, this is 2SO4 plus 2SO4. So this one has been eliminated. 2Ki, 2Ki, you eliminate it like that. So we are left with this now. Fe 3 plus AQ plus, this one has been eliminated, this one has been eliminated. So we are left with 2I minus AQ to produce 2Fe 2 plus aqueous plus I2. Sorry, I forgot to write I2 here the other time. So we have plus I2. So this is the ionic equation. Now, if you want to write the oxidation half now, don't forget, I told you that we are using two definitions. And what are the definitions? Increase in oxidation number and loss of electron. So if you look at this ionic equation now, let's rewrite it. Fe 3 plus aqueous plus 2I to give 2Fe 2 plus aqueous plus I2. So going by that definition, the first thing you look at now, you first of all find the oxidation number. Oxidation number. If you look at this now, the oxidation number of ion here is plus 3. This one is minus 1. The one here is plus 2. This one is 0. So by definition 1, which is increase in oxidation number, if you look at it now, which one increases in oxidation number? You will see that this is plus 3 to plus 2, that is decrease. This is minus 1 to 0. So we can say we have increase in oxidation number from iodide ion to iodine molecule. So let's write it. By definition 1, which is what? Increase in oxidation number. So we have 2I going into what? I2. Let's go by definition 2. By definition 2, definition 2 is telling us to define oxidation in terms of electron transfer, and we say is what? Loss of electron. So if it is loss of electron, this implies that this one, 2I aqueous, we lose 2 electrons to give I2. But in chemistry, we don't write a negative equation, so you have to rewrite it like this. So it will now become 2I minus aqueous going into I2 plus 2E. So this is now the oxidation half equation. I hope you got it. Follow me on this same channel at Early Chem where I'll be discussing the second part of the half reactions, which is reduction half equation. And at the same time, I'll be talking about what we call net equation, that is overall reaction for ionic redox reaction. Don't forget, follow me at Ellie Scheme, share and like.